Bismillahirrahmanirrahim. The topic of this lecture is selecting a sample through probability or random sampling technique. Now, previously we discussed that sampling is the process of selecting a few people, objects, items, or any other data that is a sample from a bigger population, the sampling population, to become the basis for estimating or predicting the prevalence of an unknown piece of information, situation, or outcome regarding the bigger group. If you have identified your target population, then from that you collect a representative of the population as the sample. And there's common reasons for using samples in research is it is almost impossible, impractical to survey every member of a population, and therefore you select some members of the population, you select some a sample from the population, target population, and therefore you draw. It allows for inferences about the characteristics of the population in general, and the samples which you have taken are also helpful in representation of the population in question or under study. We discussed that there are mainly three types of the sampling, that is random or probability sampling designs, non-random, non-probability sampling designs, or the mixed sampling designs. Today we will be talking about the random or probability sampling designs. When each element in the population has an equal and independent chance of selection in the sample, such design is called random sampling or probability sampling. So there are two important considerations while considering a sampling as random sampling. When number one is equal chance and number two is the independent chance. Here, from a population, an equal chance of selecting the sample implies that the probability of selection of each element in the population is the same. That is, choice of an element of the sample in the sample is not influenced by personal preferences. Every element, every sample has got an equal chance to be selected as the study sample. And another important characteristic in the random sampling is the independence. That is, the choice of one element is not dependent upon the choice of another element in the sampling. The selection or rejection of one element, it does not affect the inclusion or exclusion of another element or component. That is, one element or the sample is independent for selection or inclusion of some other sample. It is not dependent. And a sample can only be considered as random or probability sample if both of these conditions are met. That is, each sample should get an equal chance of selection and they should be independent. Otherwise, if you don't include these criteria, then biasness can be introduced into the study. The step of conducting a simple random sampling is, first of all, you just make a list uh, to your sample, to the participants, to the data, to any phenomena under study. You assign sequential number to them. To let's say to each participant of your study, you assign them a special ID, special number. You first make a list, then they assign them a sequential number, and then you can use, let's say, by simple random sampling, you can use you can do it by yourself, the random sampling, or these days you can use some software, the help of a formula calculation, that can be, or simply randomly you select it. Even these computer applications, they are also available, which can help you to generate some random sampling. Random sample numbers are numbers, these are called as the random number generator, which is in computer software. It will just, if you give them a sequential number, let's say 1 to 100, and then you just click one, you decide that I need random sampling, you just click one button and some random samples, or the first one can be 2, second one can be, let's say, 5, third one can be 6, then next can be 11. So a random number will be generated, and those number will provide you with the sample size, then provide you with the sample, and previously decided by your study plan, Let's say out of that 100 sequential numbers, you already have decided you'll just need 15 or 20 representative of the population from those first 100. So that depends what is your sample size. Accordingly you choose those random numbers. For example, there are 80 students in the class. Assume 20 of these they refuse to participate in your study, and you want the entire population of 80 students in your study, but as 20 refuse to participate, you can only use 60 students. And now the 20 students who refuse to participate could have strong feelings about the issues you wish to explore. But the problem is, if they are not included in the study, then their perception, their input in the findings of the study will not be included, which will not be reflected in the opinion, and there might have very significant input for the study. Now, this, if you cannot include, let's say out of 80, you cannot include these 20 in the study, which means each of the 80 student does not have equal chance of selection. Therefore, in such case, your sample does not represent the total class. If you just, 20 of the students, they have just they are not participating into the study, and you are just restricted to the 60 students, and then those 20, in random sampling, this number is the inclusion criteria will be random. However, it is not barred by any sort of refusal or acceptance towards the study. All members of the study will equally be involved, and among them, these, let's say, the nuts, based upon the sample size, you are going to select the number which is required, but randomly. It should be random. It should not be on convenience of yours. It should not be based on rejection or refusal of the some of the participants. It should be based on pure random sampling. Otherwise, biasness might include. And for independence, that was the equal chance. And for independence chance, let's assume you again have 5 students who are extremely close, and one of them is selected but refuses to participate because other four are not chosen. So therefore, you are forced to select either the 5 students or none, and then your sample will not be considered as independent sample, since the selection of one is dependent upon the selection of others. The friends, they have said, okay, if you don't include my friend, then I won't be participating in your study. Now independence has gone. You are dependent on the inclusion of one participant for inclusion of, let's say, rest of the four. Therefore, this is not an acceptable random sampling. Then same could happen in a community where a small group says that either you include all of them in the study or none of them will participate in the study. In such situation, again, where you are forced to include or exclude part of the sampling population, then the sample is not considered to be independent, and hence is not representative of the sampling population. A sample, whichsoever you are collecting, it should have an equal chance, it should have an independent chance of selection, and therefore these are the criteria which should be considered. There are different advantages of random sampling, probability sampling. For example, it is the easiest method of data collection that is available for research. It's a simple, let's say you have 100, let's say, total sequential order participants. You simply, amongst them, you simply collect, randomly select just, let's say 25. That depends upon your sample size. And therefore, it is comparatively very easier method of data collection. And if is these population represent the total sampling population, the inferences drawn from such kind of sample can be generalized to the total sampling population. Therefore, that is importance of even other sampling techniques as well. Some statistical tests based upon the theory of probability can be applied only to the data collected from random samples. So that is a prerequisite for some of the statistical test applications, that you need to have collected the data, the samples through random sampling. Only then those specific statistical tests they are going to be applied. And random or probability sampling, it requires less experience and knowledge to complete the work in comparison to other sampling techniques. There are certain disadvantages to these random sampling as well. Number one, it can require a sample size that can be too large to be representative of a population. At times, when you're selecting some samples randomly from your main population, So you might need a pretty high number of sample size to be representative of a population. It's not, let's say you have let's say 1,000 participants of the study, and you use it, since you have got this option of change selection, easy method of selection, you just decide, okay, I'll just take out of 1,000, I will take just 50 sample. So ideally, sample size, since it's a random sampling, ideally it should be comparatively higher sample size. So it requires a bigger sample size to be included in a random sampling technique. Random sampling does not provide a guarantee that the data and conclusions will be accurate. This is the problem with random, maybe even subsequent sampling as well. You know, because since this is one of the, you can say, problem with collecting representative of the population, or representative of the subjects, or representative of the any item, and even representative of bacteria, let's say, or some sample of that, they then do not guarantee you that data will be accurate, because you are not taking the whole population into consideration. That is the limitation of the research, and especially its random sampling technique. It cannot predict the future, because individual can change their mind frequently. Individuals, let's say you are sampling, collecting sample, there are some questionnaire, there are some data that is being taken, that has been extracted, and then you cannot, based upon data, you cannot predict the future. And the random sampling, the data, it varies. It is only applicable to that point of time at which you have collected the data. The information provided by the participants of the study, or that is provided, the data provided by your sample, by random sampling, it is for that point of time only. So it does not predict the future proportion, future at future of the sampling of the samples, because individuals, they may variate about their thinking, and it can variate their mind frequently. So this is the another limitation. You cannot predict the future, because they can change their mind frequently. Thank you so much for listening to this talk. Thank you.